Bohr Models, Valence Electrons, and the Octet Rule. Recall that atomic number is the same as the number of protons in a neutral atom. The mass number is the protons plus the neutrons. The number of electrons is equal to the number of protons in a neutral atom, which is what keeps the charge neutral. And electrons are found in what we call energy shells or orbitals. We also know that the first energy shell can hold a maximum of 2 electrons, the second shell can hold 8, and the third shell can hold 8. So Bohr models, Niels Bohr, one of the people we studied in the history of the atom, his design helps us understand the placement of electrons in their energy shells. And so to draw a Bohr model, what you need to first start with is kind of the kernel in the middle, the nucleus. And in the nucleus, you would draw the symbol for the element, such as C for carbon. And then using your periodic table, you figure out how many protons and how many neutrons carbon has. In this case, it has 6 of each. And then you would draw orbitals to indicate how many electrons are in each orbital. So for carbon, we have 2 electrons in the first orbital, 4 electrons in the second orbital. And since we have 4 plus 2 equaling 6, this is now a neutral atom. So we have the negative charges balancing out the positive charges. If we do the same for sodium, sodium has 11 protons. And for Bohr models, we don't really care about how many neutrons there are in the nucleus of the atom. In the first shell, 2 electrons. In the second shell, we have 8 electrons. And in the third shell, we have 1 electron. So we have a total of 11 electrons. You always fill the shells from closest to the nucleus going out. And if you can, you always put a maximum number of electrons in a shell before you move to the next shell. These valence electrons are the ones that occupy the outermost energy shell. They're the ones that are involved in bonding with other elements. So you can see here sodium has 1 electron, and out of 8, only having 1 makes this a really unstable atom. This atom really wants to bond with something else to make its outer shell full with 8 total electrons. So now, if we look at oxygen, we have 8 protons. In our first 2 shells, we get those 8 electrons to balance it out. We know that this second shell can have a maximum of 8, so oxygen is a somewhat unstable element. It wants to bond with something that can provide 2 more electrons, something such as hydrogen. Hydrogen has 1 electron in its outer shell, so it readily bonds with oxygen, and then we get 2 hydrogen atoms bonding with 1 oxygen atom gives us something we require every day, and that's water. And that's because hydrogen has 1 electron just waiting for another element to bond with. So the octet rule tells us that the most stable electron configuration that an element can have is a full outer shell. That can either be 2 or 8, or if we're looking at elements lower in the periodic table, it can be more than 8. Atoms combine with each other in order to achieve that full outer shell. They can either lose or gain their valence electrons. Noble gases, however, are the only elements that do not need to bond because their outer shells, or their valence shell, is already full. So how many electrons does sodium need to lose in order to have a full outer shell? Well, we've talked about sodium having 1 electron in that outer shell, so it needs to lose that 1 in order to be happy. If it loses this 1, its next shell is already full, and then it will be happy. How many electrons does chlorine need to gain in order to have a full outer shell? So we've got chlorine here with 17 protons. It's got 2 in the first shell, 8 in the second shell. that leaves 7 for the last shell. To make that last shell happy, it needs to gain 1 electron. So as you can see here, if sodium gives its valence electron to chlorine, they both satisfy the octet rule and they become bonded as NaCl, which is something you probably eat every day. This is table salt. So on to ions. An ion's formed when an atom loses or gains electrons. We've got something called a positive ion. This is formed when electrons are lost. For example, potassium has an extra electron beyond an octet and would be more stable without it. So it's going to donate that electron very readily. This is why potassium is such a violent reactor. When potassium gives up the electron, it'll still have 19 protons and now 18 electrons with a total charge of +1. Positive ions are called cations. And here you can see potassium. It's hard to tell here, but the +1 is written to indicate that this is a charged atom, so it's an ion. Likewise, there are elements that wish to gain electrons to achieve the octet rule or gain nobility like the noble gases. So they're going to gain negative charges like oxygen. If there are any questions about the octet rule, please let me know.